Hello everyone. So in this video we are going to study about prime numbers. Okay. So let's get started. So our problem statement is finding the next prime number. Okay. So we will keep on finding the next prime number until the user chooses to stop asking for the next one. Okay. So let's see. So what is the naive approach of finding a prime number? Okay, so if a number is a prime or not, so what is the naive approach? The basic naive approach is we let's say we have a number 29, we want to find that 29 is prime or not. So what we will do, we will start with dividing it with 2, then 3, then 4, then 5, then 6, then until the half of the number, until 29 by 2. Okay, so this is the very new approach, and the time complexity of it goes very high. So if I use a very high number, like let's say 1 lakh, so that's a very high number, although 1 lakh is very small number in comparison to okay, let's leave it. So that's in basic approach that will take a lot of time, so we don't want that. And the second thing is it is if it is divisible with any of the number in between 2 and 29 by 2. If it is divisible with any number, so it will not be a prime number. Okay, and if it's not divisible with any of the number in between them, so it will be a prime number. Okay, so this is the approach, very naive approach, but we won't be using this one. A more effective solution will be iterating from 2 to under root 29, not under root 29 by I. Okay, so this will decrease the time complexity, right? Not 29 by 2, it will we will be using here under root 29 by I. Okay, so the same thing, if it is divisible with any number in between, so it will not be a prime number. So if it is not divisible, so it will be a prime number, that way. And the way we will be using here is we will be eliminating all the non-prime numbers in between. So we will see how we'll do that. The okay, so this is the main function. How we'll use our choice and all that. So we first have our outer loop. So outer loop is basically for asking again and again if you want to continue or not, if you want to continue or not. And the inner loop is for finding the prime number. So if it is a prime, if it is a if it is found the prime number, so it will come out of the loop and print it. If it is not a prime number, it will again go to the loop. So I have written here until not found, so it will keep on iterating until it does not found the prime number, the next prime number. Okay, so this is what it is doing. So we will see in the code. And this is our main code, main prime number. How will main function, how will find our prime number. Okay, let's see how it works. So the very first line is if I enter any number less than or equal to 1, so it won't be a prime number, so it will basically return false. So it says it is not a prime number. Okay, so after that, if I if it checks if a number is less than 3, so I have eliminated all the number before 1 including 1. Okay, so it will go to this statement after this one. Okay, so here I left with only 2 and 3, so both 2 and 3 are prime numbers, so it will return true. Okay, after that, if any number is divisible with 2 or 3, so it won't be a prime number. So I have eliminated all the divisibles of 2 and 3 in this one, so it will return basically false. And if the then I will check for 5. Okay, one thing here is we are not checking for 4, because if a number is divisible by 2, so it will be divisible by 4 also, or it is opposite. Let's see. Oh, sorry. Yeah, if a number is divisible by 4, so it will be divisible by 2. Okay, so, and I have already checked for 2, so I don't need to check it for 4. Okay, so I will directly check it for 5 and the next elements. Okay, so I will check it for 5 and until this is the I have taken the math dot square root under root n, so it will check the number until the square root. So it is the previous one. So as I have eliminated all the numbers before, so why I have not specified here 2? So because I have eliminated all the numbers before that, so like 1 3 2 and all that, and 4 also. So I have not taken all that, so I have previously eliminated them, so I need not to take it again here. I will start from 5, and then we will take a step of 6. And why 6? It's because the 6, I've taken the step of 6 each time, because initially if we start with 5, then we will do not need to check it for 6, because I already checked it for 3 and 2, so need not to check for 6. Then I will check it for 7, so that's why I've taken here I and I plus 2. So 5 it will check for, and then it will check for 7 at the same time in the same loop. Okay, then in the second times and 8, so it not need not to check for 8, because I have already checked for it 2, so need not 8 is not required. Then 9, again I don't need to check for it 9, because I already checked it for 3. And then for 10 no need, because I have already checked for 2. And then again comes 11, and then 5 plus 6 is again 11. Okay, so I will check for 11 and 13. Then for again again that way I will increase it with 6, and then I will check, because it's because all the inner between elements all I have already checked, so I need not to check it for again and again. So I will just eliminating the needless elements here. Okay, so this is the way. So if it is visible with any of them, so it will return false, and if it is not in any of them, I have specified 4 conditions here. If it is not any of them, so it will return true. So true here means that it is a prime number. Okay, so this is the way we'll be dealing with here. And have you ever thought, is there any other best approach you can use to find prime numbers? So that's your homework. Let's see how we can use the best approach to find prime numbers. Okay, it's time to let's try in our code. Okay, let's try it. So we'll first define our function def. uh, Def is prime, let's say. We'll pass our element to be checked, and let's leave it empty right now. Then we will first define our main function. If name equal underscore main. So this way we'll define our main function. Initially we will take n equals to 2, so because n is 2 is the first prime number. Okay, so then we will take outer loop for taking choices again and again if I want to continue or not. So for that, while true, so it is a infinite loop, so it will continue until I don't want to come out of the loop. Okay, then we will find found equals to true initial. Oh sorry, false. Find equals to false, so I don't want that. Okay, then I will use while not found, so it will keep on iterating until it does not the next prime number. So while not found. Okay, so initially it is initially the found is false, so when it will not found is basically true here. This one is true because found is false, so not found is true. So it will keep on iterating into the loop until found becomes true. So when found becomes true, not found becomes false, and it comes out of this loop. Okay, so this way. Okay, let's see. Then I will answer as equals to is prime. I will call the function here is prime and pass the value n. Now I will check if answer is true. Then if answer is true, it will print n, and if it is, and then I will increase it with 1, so as to check with the next number. So plus equal 1, and then I will make found equal true. So because I have found the number, so I will make it as true, and if the number is not found, so it will just increase the value to 1, so as to go out to the to the loop again and again until it does not find the prime number. Okay, then I will ask for the choice and then I will take the input. Then I will ask if you want to continue, yes or no, y/n. Will ask, so I will ask choice choice equal capital N or choice equal small n. So if it is any of this, so it will break the loop and it will come out of the loop. Okay, so this is what we will be doing. And if I press any other key other than capital N or capital N or small n, so it will keep on executing the loop. So it will, I press enter or any other key, so it will keep on executing the loop. Okay, now let's define our main function. So I will check if the number is n is less than or equals to 1. So no way it is a prime, so I will return simply false. Okay, now if the number is, so I'm not using else if here because I want to execute each with each time, so I don't want an error here. So I won't be using else if. So if I use else if, it will be checking only the first element, and it will, if it checks the first one, it will not go to the second one. Okay, so I won't be using else if here, remember that one, so don't try that one. Okay, so if I use nest n equals n less than equals to 3, so it will return true. So because it is talking about only 2 and 3, so and both 2 and 3 are prime numbers. So now if I check the divisibility of 2 and 3, so if n percent 2 equal 0 or n percent 3 equal 0, so return false. So if the number is divisible by any number 2 or if it is divisible of 2 or 3, so it will basically return false. Then I will iterate through the bigger loop. As I told you, it won't check for 4 and any other divisible of 3 or 2. Okay, so we'll check only the other elements that are left here. Now I will check for I in range, and range will be 5 until okay, for that firstly I have to import math function here because I will be using that one, import math. And then okay, let's come here again, math dot sqrt and n and then plus 1 is because it will return it will be a little confusion inside the typecasting, yes, because in this one it returns floating values, so it directly does not return integer values, so I have to specify it with this one, and each time we take a step of 6. Okay, so now I will check if the number is divisible by with any of this number between this loop. So if n percent I equal 0 or n percent I plus 2 equal 0. Okay, so it firstly will check for 5 and 7, then it will check for 11 and 13, and then so on. Okay, so it will check, so if it is divisible with any of the number, so it will just return false. And after this, if it comes all this way down here, so if it is not divisible with any of that number, so it will basically return true. So that means the number is prime number. Okay, now let's try to run it. So initially it has already initially it is printed 2, so 2 is the first prime number. Now I want to continue, so I will press enter. So it prints 3, then it prints 5, then it prints 7, then it prints 11. So it's keep on printing the very next prime number until I'm pressing any other value other than n. Okay, so 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, and all that number, as you will see, it will keep on printing the very next prime number until you keep on pressing the enter number. And now I will press n, so it will come out of the loop. so it comes out of the loop. So that's a very simple example of how we'll find the next prime number. So I hope you understand it very well. To make the best out of it, just try it on your own. Okay, so thank you very much for this video.